Okay, so on to section 3 we go. And I always, this is like an introduction to chemistry, and I always open with this question. What is chemistry? What is it? And so I'm a little bit sad, actually, that I'm not having this class in person right now, because I always enjoy hearing what you guys expected of a chemistry class and then not doing any of it. That's my goal. Like, if people are like, oh, I always think about beakers. I make sure to never bring a beaker in the classroom. Or test tubes. I hide all the test tubes in the building from you. That's what I do. So I won't know what to take away. So this is a very sad moment for me. But you can take a second and reflect to yourself. What you would expect out of chemistry. Maybe you expected a desk with paper and writing with a question like, what is chemistry? In which case I've already failed because I have delivered that, and that was not my goal. So there's kind of a textbook definition, but just an example. A lot of times people throw out glassware, like I said, or like chemical reactions, or there's like always a classic like movie scene where there's glassware bubbling in other glassware and things are happening. But who cares about that? Because there's kind of an official definition, and maybe you've already read the book and seen that, or you're seeing it for the first time. But so what we have is chemistry is the study of matter and its changes. And for some of us, it's even a career. But, you got to pick up a lot of trash on the highway before you get this job, let me tell you. Wearing that orange jumpsuit. Like this guy right here, that's a future chemist. Okay. So matter and its changes. So that's what we're looking at. So there's quite a few details about matter. This is a very rough introductory section. We're going to talk more about this stuff next week. We're going to build on this even more. So right now it's just very general ideas and definitions. So we're going to start out by talking about matter, and then what causes changes in it. And so there's a couple details about matter. So the first thing is it is particulate. That's a U, by the way. I'm sure you all knew that. Basically, it's made of pieces. So it's made of pieces. There are like little whole pieces. So, and it's changeable as well, which is good. Otherwise, when you ask the question, like, can people really change? Well, they're made of matter, so yeah, they're changeable. I mean, maybe not like personal growth wise, but like your fingernails get longer and your hair can look different. So yeah, people are changeable. And let's see. So there's a couple different ways it can change. Talking about matter now, not people. So there's physical, chemical, and nuclear. These are all different kinds of changes. So physical is just like, it's the same stuff, but it's in a different phase. Or, it's separated or something like that. Like you can have ocean water. So it's like salt water. And you can change that. You can get pure water and you can get salt. You can evaporate the water out and just get the salt that's left behind. That's a physical change. We didn't really do any chemistry. We just kind of separated out the pieces. And to bag on Dark Ages medieval Europe a little bit longer, they act like they're so smart, but they didn't know how to get salt out of the ocean. So, joke's on them. I mean, they imported salt from India, for crying out loud. Like, they shipped it around the world. In the ocean. They had boats going across the ocean. At no point did someone go like, I can't drink the ocean, the water's too salty. I wonder if I can get the salt out of it. I think there were salt mines in Europe, but anyway, I won't give them an inch because they invented the stupid unit. Alright. There's also chemical changes. And so this is actually like taking matter and turning it into not just a different form or state or separating pieces, but creating whole new compounds, different molecules. And so these are like chemical reactions. So this is like evaporation, filtering, things like that. This is like you want a chemical change. You light something on fire. That's a chemical reaction. It is changed. And then there's nuclear. And so this is a very different type of thing. So this is like turning lead into gold or something like that, like changing what the matter is very distinctly. So it's not a chemical change, because chemical change, we're going to talk about what atoms are in a bit, but chemical change is rearranging atoms, and nuclear change is changing the atoms themselves. That's what we're doing. So matter is particulate. It's made of pieces. Those pieces are called atoms. Physical change, we don't rearrange the atoms. We just sort of, change their physical state somehow. Chemical is we do rearrange the atoms, and nuclear is we change what the atoms are. So like lead is a type of atom, gold is a type of atom, and chemistry's roots go back to alchemy, again to knock on medieval Europe, and one of their big goals was to turn lead into gold. And so they would do stuff like evaporate the water out of pee, because pee was gold colored, and try to make gold out of that. Things like that, like, because color is everything. Good to know that somewhere down the line I entered the picture from the people that tried to turn pee into gold. Like, that's the roots of my entire profession. Alright, so matter is changeable and particulate. Okay. And then the last thing is that matter is conserved. Well, this kind of got broke by Einstein, but for anything we do in the class, matter is conserved. So there's a law of conservation of matter. It means you have to have a tag before you can destroy it, before you go hunting for it. No, I'm kidding. It's a different kind of law. It's like a natural law. And so basically it means that matter cannot be created or destroyed. So if we do a chemical change, we have a certain amount of matter, and then it's just rearranged, but we have the same amount at the end. So there is an exception to this, and that's actually involving these nuclear processes. But you might have seen the equation E equals mc squared. And so that actually relates energy to matter. So matter is actually a form of kind of like condensed energy. So we are able to use nuclear processes to turn mass straight up into energy. And it's a really energy-rich source. And so like nuclear power plants are doing that to generate electricity through engineering and whatnot. But this isn't really going to come up in medical stuff. And so it's not really going to come up in this class. But if you ever take like anything with nuclear chemistry, this comes into play, and the conservation of matter is out of the picture. So I don't like to lie to you guys about the chemistry. I'll lie about myself all day. For example, I am only able to teach this class because the NBA is on hiatus, and otherwise I'd be playing in the playoffs right now. So just a heads up on that. Totally true. That's a fact. Not a lie. Alright, so these are kind of the details about matter. Now there's a couple types of matter, and that's what we're going to talk about next. But these are kind of introductory ideas. And so it's made of pieces. We call those pieces atoms. And we can do different things with the atoms. We can make them a liquid or a solid. That's a physical change. We can rearrange them to be a different compound or molecule, which we'll define in the next video. That's a chemical change. We can change the type of atom. And to do that, to understand that better, we got to talk about the structure of atoms, and that'll be the video after next. And there'll be 3 in this section. Alright, so this is kind of introduction, and it is conserved. For the purposes of this class, we're never going to break it, but I always like to talk about the exception that proves the rule. Okay, so next we're going to talk about different types of matter, so pure substances, mixtures, that type of thing.